All right. So we are given home prices from the years 1980 to 1992, and they ask us to first find a linear regression based on the years since 1980. Now, just like last time, we have to insert a new second row where we subtract 1980 from all the years. So we right-click here, insert, and we put years since 1980. And in this box, we take whatever number is above minus 1980. Should get 0 when we start most of the time, not every time. Take the black cross and auto-complete that second row. Now that we have this, we are going to use the second and third rows to create a scatter. Select the second and third row, say Insert, and select the dots for scatter. The first option is fine. And here's our scatter graph. Once again, to create the trend line, we right-click on a dot and say Add Trend Line. We can get the equation and the r squared from the options below. And our trend line is equals 3533.6 times x plus 60705. So we can say that our slope, or rate of change, is the number next to x, which is 3533.6. That means for every year that passes, the average price changes by $3,533.60. While we're here, let's go ahead and put a new row in for the linear prediction. So to make our linear prediction, we say equals 3533.60 multiplied by x. Now let's remind ourselves once again, don't use the year itself. Use the year since 1980. And then add 60705. And then black cross that over to the right, and this will make linear predictions for all 5 of our data points. Okay? That takes care of that. Now, part C asks us to get an exponential regression model. So, once again, we're going to repeat the process of selecting the year since 1980 and the home price, insert a new scatter, like before. We'll make room for it down here. Now, right-click again, add a new trend line, but this time we're not going to use linear, we use exponential. So make sure we click on exponential and then display equation and r squared. And now we have something completely different for our exponential regression model. Our exponential regression model is equals 61972 times exp of 0.0434 times x. All right. So what we can do is now come back up, enter another row for exponential prediction. And these won't be the same as the linear. So it's important to realize that a linear prediction and an exponential prediction will not necessarily give you the same thing. So we'll say equals 61972 multiply by exp of 0.0434 times the x value. Once again, don't use 1980, use the years since 1980. This will give us our exponential prediction, and we can black cross it over here to get our exponential predictions for all of them. Now, all of these extra decimal places they give you aren't strictly necessary, so I am going to decrease the number of decimal places. Let's give it 2 decimal places. And we'll do the same thing for our linear prediction, just to make sure it's in terms of dollars and cents, since we are using money. Now, for the data provided, is the linear or exponential model more appropriate? Now for this, we actually do use the R-squares. The graph with the higher R-square is going to be the one that has the better fit. Now, the linear graph has an R-square of 0.9926. And exponential was 0.9959. Both of them are fairly high numbers, because 1 is the highest you can go. So anything starting with 0.99 is fairly good. However, the exponential is just a little bit higher, because 995 is definitely higher than 992. So we'll say the exponential graph is slightly more appropriate. So all you really have to do to justify using appropriate mathematics is really just look at the R-squared. So this is why I keep saying to go ahead and add the R-squared when you can. Now, we are asked, what price does your exponential model predict for 2012? Well, to do that, when you're given a year, add that year onto the list of years. Then black cross the years since 1980 and the exponential prediction. So let's add 2012 onto our list. Okay. We take the year since 1980 from before and black cross it. This will give us the correct X value. Then let's black cross the exponential prediction. And if you see these pound signs in the box, it just means it needs to be a little wider so we can read the whole thing. There we go. So we have $248,509.90. And we'll specify that's in the year 2012. Now, we are also asked, when does the exponential model predict an average home price of $500,000? So we are not given a year. So we don't know what X should be. Now, when you don't know what X should be, we need to use goal seek. And we'll goal seek the prediction to $500,000. So we are going to click on our exponential prediction and use goal seek. So we'll click on the exponential prediction. We are going to go to data, what if, goal seek. We want a value of 500,000. And we're going to do that by changing the X value located here in the second row. So if your Excel throws an error when you try to goal seek it, go ahead and just clear the X value out and try again. Goal seek to 500,000 by changing this cell right here. And Excel gives us a value of 48.108. Now, remember that was the years since 1980. So at the very end, we have to add back 1980. We'll add that to the years since 1980, and we will get 2028. So our X that came out of goal seek was 48.1. Add that back to 1980 to get the correct year. So I'll do it again down here. 1980, add 48.1. So the average home price will be $500,000 in the year 2028, according to our exponential model. Now, if you switch to the linear model, it might not give you the same thing, and that's fine. Now, according to the best model, at what rate are home prices increasing? Let's backtrack to part D. We found in part D that the exponential graph is slightly more appropriate. So to find the rate of change of an exponential graph, we need to find the growth or decay rate. We are going to use exp of the number next to x and then subtract 1 outside of the parentheses. So for our growth rate, let's examine our exponential function. It was exp 0.0434. That's the number next to x. That's what we'll use. We'll say equals exp 0.0434 and then subtract 1. We don't want to include the x in here, we just want the number. And we get a growth rate of 0.04435 repeating. To change to percent, we click on the growth rate, then on the percent symbol in the number section. So I will click here, go to Home, click the percentage sign, and let's go ahead and increase the decimal by a couple of decimal places by clicking this button a few times, 4.436%. So we can say the rate of change in the price. The rate of change in the price is 4.436% every year after 1980. So all right, so that's a lot of things we did in this question. We got the linear regression model, we got an exponential regression model, we made a prediction when we were given a year, we made another prediction given a price, and then we found the growth rate in the exponential model.